All right, we are looking at CC2. This is 2.2.4, number 2-79. Okay, so it is, let me get that in focus. We're looking at finding the value of each of these expressions, but specifically it wants us to use a tile diagram or a number line to help. And so I'm going to show those specifically for this problem. Sometimes I'll use a tile diagram. Sometimes I'll use a number line, so that way we can see how that's useful. So for part A, I have 3 times 4, which again means 3 groups of 4. That's what we're looking for. So 3 groups of 4, and they're positives. So I'm going to show as a tile diagram, that would be 1, 2, 3, 4. So I'm making 4 positives and 3 groups of 4 positives. So this right here, here's one group, right? Another group, another group. This is 3 groups of 4. That's what it would look like as a tile diagram, right? As a tile diagram. In the number line, to show this in a number line, you would start at 0, and I'm going to go 3 groups of 4. So I go forward, I start here at 0, and I'm going to go up positive 4, and then I go up again, positive 4, and then I finally go up again, positive 4. So it's 4, 3 groups of 4, showing the addition, multiple repeated addition. So that gets me to 12. So my answer, either way you look at it, is 12. I look at count all the positives or look at the number line. Okay, so that's A. B, so B now says 4 plus 11 plus negative 4. So again, we'll use the tiles. So there's 1, 2, 3, 4 there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 positives. And then we have 1, 2, 3, 4 negatives. So the way that works with tiles is you find these pairs of positive negatives, and you're going to cancel them out. So there's my pairs of positive negatives. Let me grab this one here. So I have 4 pairs of positive negatives that are going to just cancel out of this. So I count what's left, and I got what's left is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 positives left. So that would be my answer if I look at it as with tiles. As a number line, you would start again at 0, and I'm going to go from here, I'm going to go positive 4, and then it wants me to do another leap of positive 11, and then I turn around and go backwards because I'm going negative 4 in the other direction, and the question is, where do I land, right? So I went 4 to 11, which put me at 15, and then I go backwards 4, which then ends me at 11. So I can see either way, I end up with 11. So C, let's look at C. C has the question 3.2 times 2. Now this one is a different, it's harder to see this as groups of, and even harder to see as with the tiles, because we have a decimal, a tenths here. It's 3 2/10 times 2. So really, the way to do this one is going to be looking at a number line, is drawing in a number line, which really, when I'm looking at 3.2 times 2, I'm taking and I'm leaping 3.2 twice, right? So leaping 3.2 twice on the number line ends me at 6.4. And that's what I'm looking at. When I multiply 3.2 times 2, I get an answer of 6.4, or 6 4/10. Okay, so then D, now D, we've got interesting symbols there. I want to make sure we understand these symbols. Look like so. So when I'm looking at these symbols, I'm needing to add these numbers up, but then at the very end of it, after I've done what's inside, these symbols mean absolute value. Sorry, absolute value. So absolute value. When I'm talking about absolute value means the distance to 0. Right? So distance to 0, distance is always positive. So really all it's saying is what's the positive version of whatever answer I get. So in this case, I'm taking -2 plus -2 plus -2. When I'm adding all these negatives, -2 and -2 is -4, plus another -2 is -6. But what I have is I have these absolute value symbols around that -6. So my final answer has to equal +6. Okay. And if I was going to look at the tiles version of this, it's really looking at, you're going to have 2 negatives here, 2 negatives here, and 2 negatives here. So there's no cancellation of positives and negatives. So what's left is just what I can count is 6 negatives, but I still got to consider the absolute value after the end. So it becomes a +6. All right. Let's look at E. E says the absolute value of 2 groups of -7.5 or -7 5/10. So if I'm going to multiply, first thing is inside these absolute values, I multiply 2 groups of -7 5/10 is the same thing as 15, and it'd be -15, right? A positive times a negative is negative. And then the absolute value of that, now we have -15. The absolute value of -15 is actually just +15. How does that look? I could do that one on a number line. That would be starting at 0 and working my way backwards, right? 2 groups of -7.5. So I'm going to go back -7 5/10 and do it again, -7 5/10. So that shows me that I'm ending here at the -15. But then I want to know what's the absolute value means the distance from that point to 0. Well, the distance is always a positive value. So my distance is still just +15. Okay. And last one, E, or excuse me, F. F says 10 1/5 times -5. 10 1/5 times -5. So in this case, we're just multiplying a positive times a negative. So I know my answer is going to be negative. I don't have any absolute values, no absolute value signs. But now I've got to figure out, do I know how to multiply 5 times 10 1/5? Well, what we're going to do is take that 10 1/5, this mixed number, and put it in as a fractional form, or some say improper fraction, right? So we go 5 times 10 plus 1. So it becomes 51 over 5. And then multiply that by 5. I'm ignoring the negative for this moment because I know I'm going to have a negative answer. I know my answer is going to be a negative answer. So I just need to kind of make that note and then go and do the math and then come back and grab the negative. So when I multiply a fraction times a whole number, put the whole number over 1, okay, you can multiply straight across, which you're going to get 255 over 5. Then do the division, and you'll end up with 51. And remember, we know a negative times a positive is a negative, so my answer is -51. All right, there you have it.